Hello everyone. In this video, we will explain what is a monomial, what is a coefficient, and what is a polynomial, what is the degree of a polynomial, how do we add two polynomials, how do we subtract two polynomials, and what is the meaning of representing expressions by a bracket, how do we open the bracket, etc. These all I'm going to explain with detailed examples. This class is very useful even for 8th, 9th, 7th class or intermediate first year, whoever may be. So please subscribe my channel and like the channel and keep on watching my channel. So first of all, what is a monomial? So before we explain the polynomials, what is a monomial? Mono means single. The meaning of mono means here single. So monomial means having only one term, a single expression, okay, without addition, subtraction, etc. So for example, 2x is a monomial. 3xy is a monomial. It is a single term. 2ax square y is a monomial. Now you see what is the definition of monomial. The product of numbers or letters representing constants and variables with non-negative integers, with whose powers are non-negative integer powers, with non-negative integer powers, with non-negative integer powers. So the power of each variable must be non-negative integer, means those integers starts from 0, 1, 2, 3, etc. So here the power of a variable should not be negative integer or a rational number or an irrational number. So here you see the product of numbers. So this is a number. Okay, x is a variable. That's it. So this is a monomial, means only single. Now you see here 2a is a constant or a is a constant. This is a number and a is a constant, right? And these are the variables. You can take any number of variables. You can take any number of variables, but with only non-negative integer powers. So this all comes under monomials. This all comes under monomials. You can create many number of monomials by yourself. Or I can write 2, 3, a, b, x power 4, y square, z cube is a monomial. Is a monomial. So I'll give you an example which is not at all monomial. 3 root x. So here the power of x is not an integer. 2a x to the power of 3 by 2, y to the power of 4 by 3 are not monomials. Are not monomials. Why they are not monomials? Because the power of each variable is not non-negative integer. Since here you see powers 1 by 2 or you can say indices 3 by 2, 4 by 3 are not non-negative integers. Are not non-negative integers. So that's why this expression is not a monomial. Well, in the monomial, there is a term called as a coefficient. Called as a coefficient. So here is the definition that numbers or letters denoting constants in a monomial is called a coefficient. Number or letters representing constants in a monomial are known as a coefficient. For instance, you see 3x, right? So this is known as a coefficient. Coefficient. Or I will take another expression, 4a x square y cube, right? Say this is totally constant, right? If this is constant, then it is known as a coefficient. Coefficient of x square y square y cube. Here 3 is the coefficient of x. Similarly, minus 3 by 2 x square. In this, that minus 3 by 2 is called coefficient of x square. This is known as coefficient of x square. So if I ask what is the coefficient of x square, you must say it is equal to minus 3 by 2. Either a number or a letter denoting constants. Right. So mono means 1. Now what is meant by a polynomial? Poly means more than 1. Poly means more than 1. So here in this, what is the degree of a polynomial? What is the degree of a polynomial? So degree of a polynomial means the sum of indices of variables which is a maximum whose coefficient is not 0. Whose coefficient is not 0. So here you see the sum of all indices of letters denoting variables in a monomial and whose coefficient is non-zero, right? So the sum of all indices of letters denoting variables, here I am writing, whose coefficient is non-zero. Whose coefficient is not 0. Is non-zero. In a monomial is called degree of the monomial. For instance, here you see 2x, right? It is a monomial. So here the exponent of x is 1, right? So what is the degree of this monomial? Degree equal to 1. Well, now let us take another one. 3x square minus 2x. What is the degree here? The degree must be that sum of all the indices of letters variables in a monomial, right? The sum of all the indices. So it is not a monomial. So I will take a monomial here. 3x square into y. Into y. So here what is the degree? Here y power 1. Index is 1. Here index is 2. So here the degree equal to 2 plus 1, that's equal to 3. If I give a constant, only constant, a constant, this is a constant. So what is the degree per constant? The degree is 0. This is. You can take like that, a into some x square, y cube, z power 4. So what is the degree of this monomial? The degree of this monomial equal to, see, adding this 2 plus 3 plus 4. Sum of all indices, 2 plus 3 plus 4. That's equal to 9. Now, coming to what is a polynomial? What is a polynomial? Poly means many. Poly means many. Like a polygon. Gon means a side. Polygon means having more than one side. Poly. So a polynomial, which means that the sum of several monomials. The sum of several monomials. So if you add more than one monomial, then such expression is called a monomial. For example, I'll give you an example for monomial, for polynomial. Here you see 2x square plus 3xy minus 7x y square z. You can take in whatever way you want, you take no problem at all. So now you see the sum of several monomials. So this is a one monomial, and it is another monomial, and it is another monomial. So 2x square one monomial, 3xy is another monomial, minus 7xy square z is a monomial. So the sum of several monomials is called a polynomial. Remember that power of each variable must be non-negative integer. If you forget this, then you will be in trouble. So in this, there are several terminology are there. What is meant by a term? Each monomial is called a term. Each monomial is a term. So this is a term. This is a term. Like this. Now, what is a constant term? Right? Here, I'll write one more term so that we can understand 5. It is also a monomial. So what is a constant term? A term without variable. A term without variable. A term without variable. Without variables. Variable or variables. So a term without variables is simply called as a constant term. So this is a constant term because it does not contain any variable. And first 3 terms are not at all constant because they contain many variables. Now, what is the degree of polynomial? So same as of degree of a monomial, we can define that degree of a polynomial, right? So the degree of a polynomial is nothing but the maximum sum of indices, okay, of variables, whose coefficient is not 0, whose coefficient is non-zero. Well, so here you see what is the degree of this polynomial. degree of this polynomial equal to, remember, here the maximum sum, okay? Here this is 2. Index is 2. Here power 1, it is also 2. Here 1, 2, 1, totally 4. So the degree of this polynomial is 4. Remember, the coefficient should not be 0. The coefficient should not be 0. If coefficient can be 0, anybody can increase the degree indefinitely. Anybody can increase the degree indefinitely. So polynomials are very, very important, right? So these polynomials we can understand very clearly. It is the sum of several monomials. Several monomials. So polynomials can be in single variable, or polynomials can be in several variables. Several variables means more than one variable. So here I am providing some more examples. So here this is a polynomial. Is a polynomial because it is sum of several monomials. A polynomial of degree. What is the degree here? Equal to highest power is 2. So degree is 2. And this is also a is a polynomial of degree equal to, remember, here power 3 is there, power 2 is there, and here power 1 is there. So total power is 6. And the coefficient is non-zero. Coefficient is non-zero. And this is a constant polynomial, right? Only A. Only A. So is a constant polynomial. Because it does not have any variables. So that's why it is a constant polynomial. And you see ax plus b, here a not equal to 0, assume. Let a not equal to 0. So is a polynomial of degree 1. Is a polynomial of degree 1. This is equal. And it is a polynomial of degree equal to 2. So polynomials can involve one variable or more than one variable. Now, what is a homogeneous polynomial? What is a homogeneous polynomial? The sum of indices, the sum of indices the sum of indices of variables in each term of a polynomial must be same. Of a polynomial must be same. Then it is called as a homogeneous polynomial. So homogeneous polynomial means the sum of indices of variables in each term in a polynomial must be same. For example, one example, that 2x square minus 3xy plus 4y square. Well, here the power is 2, degree is 2. Here the degree of this monomial is 2. Here also it is 2. So is a homogeneous polynomial. So homogeneous polynomial means that sum of indices of variables in each term must be same. Is a homogeneous polynomial. Like this. Well, I'll give you another example. Ax plus bx square plus cxy is not a homogeneous polynomial. Is not a homogeneous polynomial. Because here the degree is 2, here the degree is 2, but here the degree is 1. Well, so like this, you can create means homogeneous polynomials by yourself. Ax square plus 2hxy plus by square, okay, is a homogeneous polynomial. Is a homogeneous polynomial. Homogeneous polynomial. You can take any number of variables x, y, z plus x cube plus y cube plus z cube is a homogeneous polynomial of degree 3. Well, what are the like terms? Now, what are like terms? Because if we do not know like terms, then how can we add the terms? Or how can we subtract the terms? So, two terms are said to be like terms if they have same kind of construction except their coefficients. What is the meaning of same kind of construction? Which means that whatever variables involving in terms have same kind of powers. For example, here you see 4ax square. Here x power is 2. Here x power is 2. Right? In 4ax square, 4ax square y, comma, 5b x square y. See here x square y construction, here x square y construction, both constructions same. Only they differ by a constant, no problem at all. So these are the like terms. I can give you some more examples, like terms, like 3x square y z minus 6x square y z or like terms. Minus 3 by 2x, 5x minus 6x or like terms. Well, so now we came to know that what is meant by like terms. So they must have same construction except for the coefficients. Well, so what is the use of these like terms? When we want to add two polynomials or subtract two polynomials, we must use the technique of like terms. Here is the construction that how do we add two polynomials. So two polynomials can be added, right? Which means that you have to club all the terms of given two polynomials or three polynomials or more. Right. So that is the point. Take all the terms in two polynomials as the terms of the sum. Well, okay. So for example, I'll write here one example. I'll write. Let P equal to, let us take that x square y minus 2xy plus 3x. Okay. Now let you take that q equal to xy minus xy square plus minus 5x. You take this. Okay. So take all the terms in two polynomials as the terms of the sum. Combined all like terms if any. Combined all like terms if any. So if we want to ask what is p plus q here, you see x square y is the first term. I'll write all the terms at a time now. Minus 2xy plus 3x and plus xy minus xy square minus 5x. So p plus q means the first one is you club all the terms. Now we have to simplify this. See, xy has the same construction, minus 2xy has the same construction, except that coefficient. So we can add these two, right? So like this is a one book and these are the two books. Or you can say this is 1 rupee, this is minus 2 rupee means which is borrowing someone. So like this. So x square y. Now adding these two, right? You will get minus xy. Very simple thing. What is a minus 2a? Equal to minus a. Or what is a plus 4a? This is equal to 5. Means one object we have one first time here one object, here 4. 4a is nothing but a plus a plus a plus 4 times. So here coming here 3x minus 5x. So adding together you will get minus 2x and there is another term minus xy squared. So this is the complete simplification of two polynomials, sum of two polynomials, right? Generally, arrange all the combined terms according to the order of ascending or descending degree. Okay. So it is necessary that whenever you are writing a polynomial, make sure that the degrees of the terms, right? The degrees of the terms must be either in increasing order or decreasing order. So here I did not write in that way. So again I'll write that here x square y, the degree is 3. Minus xy square, the degree is 3. Minus xy, the degree is 2. Minus 2x, the degree is 1. Here the degree is 3. Here degree is 3. Equal to 3. Same for this also. Here degree equal to 1. Plus 1, 2. Here the degree is 1. So either you have to write the terms in the polynomial in descending order of degrees of the variables or ascending order of the degrees of the variables. So whatever we have done for addition of two polynomials, the same technique can be applied for subtraction of polynomials. But subtraction of polynomials quite little different from addition of two polynomials. Well, in this, there is a big point that what is the rule for removing or adding brackets? Because in mathematics, putting brackets play a vital role. Sometimes it may confuse you like anything. So how do we open the bracket before we add or before we subtract, right? And what is the procedure for opening a bracket? So opening a bracket or adding a bracket is nothing but a distributive law. What is meant by distributive law? Very simple. Suppose you consider that some a into a into a into. So in place of that multiplication, I will write bracket b plus c. This is equal, right? So this bracket indicates that multiplication. So a into b, ab, plus a into c, yes. So this is called as a distributive law. Whether you have positive sign or a negative sign. A into, suppose we have b minus c. Then we write ab minus AC. These are known as distributors. Now, the point is, for example, suppose I have that minus A into some B minus C, right? So how do we write? Minus A is a quantity. Minus A into B. Minus A into B, right? Next here you see this is minus A, this is minus C, okay? So minus A into minus C. So negative into negative is a positive. So therefore minus AB plus AC. Well, we have to use that theory of indices to simplify the addition or multiplication or subtraction of polynomials. For example, minus 2x square y into, let us take that x y square minus 4xy plus 5y minus 3x. Let us take this. How do we do? Very simple. Just you multiply this term by each term inside the bracket. By each term inside the bracket. So you have to multiply these two. Which means that minus 2, okay. Here x power 1 into x square is x cube. And y power 1 into y square is y cube. Done. Now multiplying with second one. Here minus sign is there. Here minus sign is there. Minus of minus becomes plus. Plus. X square into x is nothing but x cube. Of course, you have to multiply the constants. Here minus 2 we have, minus 4 we have, okay. Or I can say that I will write term by term like this, minus 2x square y into xy square, okay, plus 2x square y into 4xy. That minus into minus becomes plus. And plus into minus is minus. Minus 2x square y into 5y. Again, plus minus into minus plus 2x square y into 3x. This is the process. Now further we simplify this as minus 2 times of here x square into x is nothing but x cube. X is multiplied 3 times and y is multiplied 3 times. Plus 2 into 4 is 8. Again x cube y square. Minus 5 into 2 is 10. X square. Here y into y is y square. Minus 2x cube, 6x cube. 6x cube y. So I am telling frankly that the process of simplifying expressions is very typical. Multiplying two polynomials, adding two polynomials, subtraction of two polynomials, simplification of polynomials are very, very important in entire mathematics. So here, this is the procedure that how do we open a bracket. To simplify these polynomials or whenever you are multiplying terms of polynomials, we must follow the exponential laws that a to the power of m into a to the power of n equal to a to the power of m plus n, okay, and a to the power of m by a to the power of n, we write as a to the power of m minus n, a to the power of m whole to the power of n equal to, this is a to the power of mn AB whole to the power of m equal to A power m, B power m, or A by B whole to the power of m equal to A to the power of m by B to the power of m. Of course, particularly for this B not equal to 0 and m comma n here, we take that natural numbers. So these rules frequently we use simplifying the expressions, and here A power 0 equal to 1 when A not equal to 0. So to understand this concept clearly, you can watch that exponential laws in my channel. Simplify this expression. Once again, I'm telling that minus of minus equal to plus. Minus of plus equal to minus. Plus of minus equal to minus. So these three rules are very, very important. So we have to simplify this expression by opening the bracket. By opening the bracket. So this expression equal. Okay. Here 3a you write as this. Well, we will do what we will do. We will simplify this inside the flower bracket first. Minus 4b. Okay. Minus this bracket is there. 4a, or first we'll simplify that this innermost bracket. 4a minus 7b. Here you see minus of minus plus 4a. Again minus of minus plus b. Bracket closed here plus 5a, and again curled bracket, flower bracket. So this is equal to now 3a. It seems to be very simple, but difficult also. Minus 4b. Now you see you have to simplify this inside bracket one. Here 4a like term 4a, totally 8a. So minus of 8a. Minus 7b plus b minus 6b. Like this. Plus 5a. 1 by 1. This further equal to 3a plus. Now you see minus of plus. If nothing is specified, which means that positive sign. So minus 4b here. Minus 8a. And here minus of minus plus 6b. Here plus 5a. This is equal to 3a plus, here now, plus. Here you say, here 6b we have, here minus 4b, totally 2b, minus 3a. Further, this is equal to 3a. Now you see here plus into plus is nothing but plus 2b. Whenever plus sign is there before the bracket, directly you can open it. Minus 3a. This is equal to 2. So the simplified expression of this is 2b. So I have given few examples here. You can simplify them. Now, first example is simplify the expression. Answer is minus 18x. You please practice it. Here, open the bracket, which means that open bracket, write the terms individually. P is a polynomial. Q is a polynomial. Find P plus Q and P minus Q. Just add the two polynomials directly and subtract one polynomial from the other polynomial. Okay. In the next video, I'll explain how to represent a polynomial and what is the polynomial in single variable, After that, what is a remainder theorem, etc.